English if that's all right. So first, here's what we're going to do in this lecture. We're going to go through everything that we went through last week, and it was a lot of material. To be clear, I guess I should have specified this. You don't really have to understand everything we went through last week in the first setting because that's a lot of content. And we will actually be going through more of those in detail today. So basically, we'll be covering a lot of same things, but in more depth. So in today's lecture, we'll be covering conditionals, so if, else, elif. We'll be covering loops. We already mentioned while loop last time, and we'll also mention for loop this time. And we'll dive deeper into functions. All right. First, does anyone have any specific question from last week's lecture or homework? All right, if you think of any questions, feel free to either write it in the chat or just say it. And we can start today's lecture now. Do you see my screen?
Yes. Yeah.
All right. So I'll have this here. Yeah, you can write anything. I'll check in chat. All right. Let me just. Yeah. What do I? My order. All right. So last time we covered these things. Let's just go through them again. So we covered that these are variables, which just means that they can hold some value, and we give them a name. For example, this one holds a value of 4.5. The B here holds a value of 4, A holds a value of 3, D holds a value of is 3 more than 4. So it's either true or false. In this case, it's false, so D is just false. E in this case is text, this text right here, and F is also a text. So we covered that these are the different data types in Python. So we can have integers, which just means whole numbers. We can have floats, which is just decimal numbers. This point. We can have booleans, which just means some statement that is either true or false. So this can be is 3 more than 4, is 4 equal to 2 plus 2, and such things. And we can also have strings, which is just a piece of text. And these are our main data types, and we work with this throughout our course. What else we covered here? We covered printing. Let's see what printing was, just to remember. Here we can see E plus F, which was in this case my name is plus Nika, gave us my name is Nika. So we can see that print just outputs on the screen the value of whatever variable we have here. So in this case, E plus F becomes a new variable, and it's my name is Nika. We also have operations, as you can see here. So there was addition, subtraction, multiplication, division with rounding down to nearest integers. So that, for example, 10 by 3 would become 3. Well, 10 by 3 would be like 3.3, something like that. We also have power. So this just means a to the power of b. So like 2 to the power of 3 is 8. 4 to the power of 2 is 16, and so on. And we have modulus, which is just what is remainder after division. So in this case, 10% 3 is equal to 1, 11% 4 is 3, 10% 2 is 0, and so on, as you can see here. Let's just comment this out again. What else did we cover? We covered that we can add an integer and a float to each other, and we can add a string and a string to each other. Those are the different operations we can perform. And also we can convert them. So sometimes we will need to convert some number to a text. So for that we have str function, which takes a number value and gives us text. So in this case, age was 21. And now it became a string version of 21. And because of that, we can then print it on a screen. So if we try to say my name is and name and then I am and age years old directly, we would get an error because we can't add a number to a string. But if we convert this to a string, then we can do this line just fine. So let's just go through what is going on in this line. So first we said that age is 21, name is Nika, and age as a string is just text version of 21. So age was 21 like this, then it became 21 like this, so just in text. And here we say my name is plus name, and I am, and age is a string years old. Is this clear?
Yes.
Yes.
All right, great. Now let's move on. Now, as you remember here, we went through this example problem of calculating our weight on Mars. Let's just quickly remember what that was. So basically, we had this problem that we know our weight on Earth, and we know that on Mars, our weight is going to be 38% of whatever it was on Earth. And so we had to calculate weight on Mars and put it on the screen. So what we did was we got this Mars weight coefficient, which is 0.38, because that's what 38% is. Then we multiply our weight on Earth by that coefficient to get the weight on Mars. And then we converted that to string so that we can print it on the screen. And we say weight on Mars is, and then that weight on Mars. Then we wrote a function. In this case, as you remember, function is just any place where we group a bunch of code so that all of it executes when we call the function. So here's what that means. Here we have a give weight on Mars function, which takes as input a weight on Earth. It calculates the weight on Mars like we did previously, and then it prints the weight on Earth, prints the weight on Mars, and prints just a new line on a string so that there's a gap in our text. And then we just call it with a value of 150, value of 200, 150. So the point of this is that now for each of these, instead of writing out all these lines individually, all we had to do is just call the function and pass our arguments. Now there was another type of function which maybe doesn't receive any argument at all and simply just writes something to the screen. This is the right stuff on screen. And there is also a type of function that receives some arguments and returns a value. So in this case, we wrote a function that would give us a hypotenuse of a right triangle. So we know that a squared plus b squared is equal to c squared. And from that, we just got that c is square root of a squared plus b squared. And we just know from math that square root is same as power of half. So that's why we said that square root for a plus b squared is the same as a squared plus b squared to the power of 0.5. And that's how we got our hypotenuse. And we got it here. So if our a was 3 and our b was 4, our hypotenuse would be 5. And in fact, I believe we print that here somewhere. Yeah, right here. We write that as 5. And then we come down here and we had some basic interactions with conditionals. Let's see what we did. So we said that age limit, if some age limit is 18 and our client's age is 25, here's what checks we would have. So we say if client's age is more than or equal to age limit, then we write a colon, and everything we write afterward has to be inserted in here. So with a tab, it has to go in. And anything that's in here will only execute if this is true. And anything in the else will only execute if it was false. So in this case, 25 is more than 18. So, okay, you can drink is what we'll see on the screen. Right here, we see it. And this is just one example of an if-else. And we will be just pretty much covering this with a lot more examples throughout this lesson. Now, what other examples did we have here? We had calculate ticket price. So let's say that our rules were that for anyone under the age of 8, the ticket is free. For anyone between ages of 8 and 17, ticket costs $5. And for any adults, ticket is $10. So in this case, we would say if age is less than 8, then the price returns 0. Otherwise, elif means if this was not true, and also this statement. So elif age is less than or equal to 17, then price is 5. And else, which means that age is at least 18, price is 10. So in this case, what we do is when we call this function, we get a number, and then we can just put it in a variable, write it on the screen, or whatever we want with it. So pretty much generally, a function we can either use to write something on the screen directly, Or what is more common is that we can have a function return a value, and then we would use that value somewhere. Maybe put it in a variable, write it on the screen, write it to a file, send it over the internet, or whatever we want with it. But yeah, returning values from a function is the more common approach. So in this case, we had just some calls. And also we had a while loop in here. Let's see what this used to do. Let's fix it as well. So in this case, we said, let's say our countdown is equal to 5. And as long as it's more than or equal to 0, we print the value and we decrease it by 1. Let's just run this again to see what that means. Here we can see what this means is that we see on the screen it's 5, 4, 3, 2, 1, 0, because 0 was still true for this. And then we come to this line and we see countdown is now -1. Because once we're done, we're done. And then the last thing that we started to get into the last lecture, but we couldn't completely get into, is this. We can actually get the input from the user. And let's start that in a new tab here in our lesson 2. So let's start with the most basic example. Let's say we want to know what the name of the user is. Here's what we do. We would say input, what is your name? And here's what this will do. Let's just say print hi name. So when we say input like this, here's what happens. When we run this, here we see on the screen printed what is your name, and it's waiting for us to say something. So let's just say, I don't know, Harry. In this case, you'll say hi Harry. This is because whatever we write in the input becomes the text value put in the name. And then we can use this text same as if I was to just directly say Harry here. So as far as the rest of the code is concerned, writing it Harry directly or taking it from the input is the exact same thing. Now let's say we want to check something more difficult. Like say we want to get a number from a user. In this case, we would also have to convert the text to a number. So previously we saw that we sometimes had to convert a number to a text because, for example, for printing text or to add text, then we had to have text on both sides. But sometimes we might also need numbers. So let's say, for example, we check for the age. Let's say, how old are you? Name and question mark. And let's just say, we will check how old the person is. Let's say they will say 20. Now we want to tell them, oh, so you will turn 21 soon in that case. How would we do that? We would have to figure out what the next age is. And we might think that next age is just age plus 1, but this actually won't work because age is currently a text. You can see here it's a string, it's not a number. And so to make this a number, we have to convert it. And here's one way we can do that. We can say age equals int age. And what this will do is it will convert whatever we wrote here, the text, into the number. So in this case, if we wrote 5, it will become 5, but as a number. And then we can just say, since we now have the next age, which is just plus 1, we can say print, you will soon turn, and just next age. But again, remember, we can't directly write a number, so we have to convert it to text again. So let's just step through this and figure out what is going on. Let me just do this. Let's observe it together. So first, because of this line, we are asked, what is your name? Let's say I write, I don't know, Luca. Then he will ask me, how old are you, Luca? So you can see here we already used the name. Here's what we did. We built the string here, which is how old are you, then the name, and then just question mark and space. I do the space just because it's prettier this way. If I didn't do the space, it would just not feel as good to write the text, but it's not necessary. And then whatever we write in here, let's say 30, he will take it in here. We will have that value in age. Then we will get the next age variable, which becomes age plus 1, in this case 31. Then we turn it into text so that we can write it on the screen. So we will see, you will soon turn 31. So this is the essence of taking the input. Pretty much these are the two main things that we'll be using input for. So either we will be taking some text, or we'll be taking some number, in which case we just take the input and then convert it to an int or float. So far, is this clear?
Yes.
All right. Feel free to interrupt me at any moment so that we can go through some more examples of a concept. And let's just say this is input. And now I want to cover conditionals one more time, just so that we can all understand it at the same time. This time, let's say here's our task, and then let's together go through how we would solve it. Suppose our task is now something neuroscience related, such as, let's say, you already covered a little bit of how neurons communicate, right?
Yes. Yes, we did.
We know that neurons have some membrane potential. It just means basically voltage, like in electricity. And we know that for neurons, there is a resting potential and there is a hyperpolarized, let's just say polarization. And what this means is that when a neuron is polarized, it goes up to plus 40 millivolts. And when it's resting, it goes down to minus 70 or so, minus 85 for refractory period. But let's just say these numbers for now. Now let's construct some task around this. For example, let's say we will ask the user what the potential is on, let's say, some device that we're measuring from. So let's just say potential right now is input. What was the potential measured by the device? Let's just imagine that we have some device that measures it. And we want to convert this into a number. So let's just directly right here convert it into an integer so that we don't bother. So in this case, this line is confusing. Here's what we do. First, we take the input from the user, which is going to be text, but it's going to be actually a number written as text. So it will be like 47 as text. And we need to convert this into just regular 47. And that's why we do this. We convert it to int. So now in this potential, we have some number. And now let's say, here's what we want. We want to say, is it polarized? Is it resting? Or did it undershoot? And here's what that means. Basically, if it's less than minus 70, it undershot. If it's more than minus 70, it's polarized, let's say. And otherwise, it's resting. Let's just simplify it like that. Now, how can we go about writing those conditions with if statements? Can someone help me with this?
I think we have to write if potential is, for example, less than 70, then
Mhm.
print undershoot.
Yeah, that's correct. Let's say. Yeah.
Um, then we need if else,
Yeah, in
or
Python,
yeah,
you're correct. Except in Python, that's called elif. But
oh
yeah,
yeah.
you're correct.
Um, if that's more than 70, potential is more than 70, then um, it is resting, I guess.
In this case, that would be polar. The way we define, I mean, we could define resting as anything from minus 70 to, I
Yeah.
don't know, like
Mhm.
0 or something. But okay, in this case, actually, let's clarify what I mean here. This is my fault for
Mhm.
not clarifying. Let's just say that under minus 70 is undershoot. Between minus 70 and let's say 0 is rest, and above 0 is polarized. This isn't necessarily exactly how it's defined, but let's just say for our case, it's this case. How would we write this? Like we already have the under minus 70 as undershoot. What's the next check if it's not the case?
I think that's, I'm not sure, but it can be if that's equal to minus 70 or,
Yeah, so yeah, you're on a correct track. And so here's what's going on.
yeah.
If it's under minus 70, we would have gone here. And if we didn't go here, we know here that potential is more than or equal to minus 70. So this part is already covered simply because we didn't enter here. So we know if we come here that it's at least minus 70. But now, basically, what's the next condition that we want to check here? So pretty much here we can see that the value has three regions. So first region is if it's less than minus 70, and we covered it here. Next region is between minus 70 and 0, and the last region is above 0. So what we need to do is somehow define this second region, for example. How could we or we could define the third region. Doesn't matter which one we write first, but whichever you want. Let's say this one. How would we check for this region? Like that it's between minus 70 and 0. What does that mean precisely in terms of more than, less than, and such? Like, for example, here's what I mean. If the value is, let's say, minus 40, in that case, is it undershoot, rest, or polarized?
Rest.
Yes, correct.
Mhm.
And how did we figure that out?
It's between minus 70 and 0.
Yeah. And how would we check here to know that? Like, let's say we will write something here, and that something will tell us that it's at rest. What is the condition for that? Like, what does it have to do to be at rest? Like, what does it mean to be between two values? You can think of it as two different statements, for example.
It has to be basically less than 0 and more than minus 70, but I don't know
Yeah.
how to
That's exactly
indicate
what.
that.
Yeah, exactly. So you'll say if
Yeah.
it's less than 0, for example, we don't need
All
to
right. Yeah.
check, and we could say and more than minus 70, or like more than or equal to minus 70, but we actually don't need to check this because we already know that if this was not true, then it's more than minus 70. So yeah, you're
Oh yeah.
correct. And now for the third case, in which case it's above 0, it's polarized. In this case, we can pretty much directly say polarized. Do you understand why? I mean,
Because
not
we already showed that if it's less than 0, that it's rest.
Yep, exactly. So if we come here, we already know that it's more than or equal to 0 because otherwise it would be covered in either one of these. Right. Yeah, thanks. Uh, this is one example of how we might go about modeling some neuroscience problem in our code. So generally, this is actually somewhat common. So what happens is a lot of the times there's some device, and we use that device to either measure potential in the brain or measure some activity in different brain areas, and then we often write some code for it to figure out, oh, this person must be excited, this person must be focused, or he must be nervous, or she must be thinking about moving her hand, and things like that. So I guess it's useful to think that the neuroscience world and the programming world are connected, and I'll try to come up with as many connections as possible. So right now, I just want to go through another example of a conditional. Let's say, let's say a task like this. Suppose we want to check. Um, what can we check? We can check, for example, which brain area some problem belongs to. How we might do that? Here's how we might do that. We might say that, for example, we have four lobes. We have frontal lobe, temporal lobe, parietal lobe, and occipital lobe. And by the way, you don't have to remember these right now. Just we'll write basically what they are. So frontal lobe is roughly, I'll use this sign for rough equality. Frontal lobe is roughly just movement commands and consciousness. This is oversimplification, but temporal lobe is roughly hearing. Parietal is roughly touch and spatial perception. And occipital lobe is roughly vision. So that's not the only jobs of these lobes. They do a lot more things, but this is just rough approximations. And let's say we have a task that we must figure out the correct lobe based on what the user asked. So for example, let's say we know that there are some keywords for frontal lobe tasks, let's say, would be equal to, and we can just write out. So here's something useful that I will introduce now, but we will dive deeper into later. This is called lists. The idea of a list is that so far in our variables, we're always holding one value. For example, if I say brain area equals frontal lobe, this is one text that I'm holding in this variable. Or if I say like age equals 20, this is also one number. But sometimes we might want to hold multiple values together. So in this case, let's just say, for example, for frontal lobe tasks, we have strings of movement and consciousness and maybe attention and morals, let's say. For temporal lobe tasks, we would say, let's just say only hearing for now. Obviously, there's more going on in there, but I'm just simplifying here. For parietal lobe tasks, we would say touch, pain, temperature, and spatial perception. And for occipital lobe tasks, we would say just vision and nothing else. And now here's a task. What if we must figure out which lobe the given task belongs to? Python actually has a way of doing that. So basically, let's say that we have some task, like movement, let's say, and we want to write on the screen which of these lobes this task belongs to. And for that, let's for now imagine that we have a function for it. So give lobe for task. We can obviously call it whatever we want. I'll just say it receives some task, which is going to be a text, and it needs to return either like frontal or temporal or parietal or occipital. So basically it has to say one of these. Now, here's what we might want to do about that. And then, yeah, later we should be able to just basically say lobe is lobe for task, let's say movement, and then write it on the screen. Actually, let's comment this out because I don't want to run this right now. And so right now we see that, oh, sorry, I missed something here. Let's comment this out as well. So right now we can see that we just write frontal on the screen, and this is just a basic skeleton. And now let's say that we want to solve this task such that we can figure out which brain area or which lobe deals with each task. So given a task, we must find which one it belongs to. In Python, actually, this is quite simple, but our meeting is about to shut down and we can restart the meeting in a moment and we'll write out this code. But just take a moment right now to look at what is going on in here. So for now, we introduced the idea of a list, which is this square bracket. Okay, I'll just continue from here. And everyone sees my screen?
Yes.
Okay. All right, so here's what I was explaining. So different areas of our brain basically do different tasks. And for each of them, we defined a list with just a bunch of pieces of text, basically. And by the way, a list could also be a list of numbers like this. But in this case, we have a list of text. And here's what I would want to do here. We would want to figure out which of them the task belongs to and print it on the screen. And maybe if it doesn't belong to any of them, then just write none. In this case, let's just say, here's what Python allows us to do. So previously we would write equalities, more than, less than, more than or equal or less than equal signs, and also like not equal sign. But there is also another thing that Python gives us, and it's called in. And here's how it works. We can say if task in frontal lobe tasks, print frontal lobe. And let's just say, not print, I mean return frontal lobe. And if it doesn't go to anything, then we would return not sure. So here's what this does right now. Because we know that a movement is in the frontal lobe, it will give us frontal lobe, but for any other piece of text, it will say not sure. So this syntax allows us to check, is this element a part of this list? So in this case, the elements are movement, consciousness, attention, and morals. And so if we write any of them, the answer will be frontal lobe. But if we write any other text, then the answer will be not sure, because this line won't execute, so it will come down here and say return not sure. So in this case, we have that, but if I miss a letter, it will become not sure. So we can then fill this up. So we can say elif tasking temporal lobe tasks return temporal lobe. And similarly, elif tasking parietal lobe tasks return parietal lobe. And elif tasking occipital lobe tasks return occipital lobe. And here's what this means. This means that for any text, basically, we can tell where it's going on. So touch is in parietal lobe, for example. Hearing will just give us temporal lobe and so on. So here's what this allowed us to do. Because we had a list defined, we came in here and we simply checked, is this task a member of that list? So we'd say, is this element in the list? And that's how this worked. Do you have questions about this?
No.
Let me see the chat as well, so I don't miss anything. All right. So if there's any question or anything, feel free to interrupt me at any moment. Now, here's the thing. So basically, yeah, we have lists. They contain elements. We can check whether something is a part of that list. And the reason why we wrote this as a function and not directly is because here's what we can do. We can say now, let's say another function that right lobe for task and takes a task. And here's what we say. We'll figure out what the lobe is, which is give lobe for task. And then we will say print on the screen task is done by lobe. And now we can just say right lobe for task touch, right lobe for task pain, right lobe for task vision, and right lobe for task consciousness, for example. And in this case, here's what we will get. We will get touch is done by parietal lobe, pain is done by parietal lobe, vision is done by occipital lobe, and consciousness is done by frontal lobe. So because we wrote this as functions, we could reuse the code for each of this. So here's what this would look like without the functions. So without the functions, I would actually have to copy this logic for each of them. So here, for example, for touch, this is what we would have to write. One moment. We would have to say print touch is done by frontal lobe. And we have to say it like this as well. Like, you understand what I mean. What I mean is it would be very messy if we did not have it as, if we did not have it as a function, the code would actually get quite messy because we would have to write it like this. Touch is done by temporal lobe and so on. So basically this would be unsustainable because we would have to write that many lines for each of these calls. And writing it like this allows us to easily change what we want. For example, maybe instead of is done by, we want to say is handled by. We only have to change it once here. And for all four of these calls, it says now changed. So it's always a good practice to try to break down your code into functions and give these functions very obvious names. So in this example, this one just figures out which lobe the task belongs to, and then this one writes it to the screen. So it takes the lobe and just says task is handled by lobe. So every time you break down a task, it becomes easier to understand. And this is very important because maybe you will have to go back to this code after a couple months, or maybe some other person who is also on a team also has to look at this code and has to understand it. So always try to write your code such that the names make it obvious what's going on and functions break down the logic so that there's not a lot of repeats. Is this clear?
Yes. Yes.
Okay, good. Now let's go into loops. Last time we discussed a while loop, and we saw that just as if works the way that basically you have some condition, and if it's true, then we do it once. In a while loop, you have a condition, and as long as it's true, you keep doing something. So the easy example we used last time was a countdown. But let's say in this case, we are talking about a reset. So for example, this is a real example of a uh, something that happens in neuroscience. So let's say potential right now is 40. And as long as potential is more than minus 70, we say still not rested, potential at, and we write what the potential is at. And then let's say we decrease the potential by 5. And then we say finally rested. And here's what this would look like. We can see here that what this looks like is that we start at 40. So for this code, so let's say because we recently had a spike, which just basically means that one neuron talked to another recently, this neuron's potential went way up, all the way to plus 40 millivolts, and now it must slowly relax and go back into rest state. And this happens over time. So here's we see it drops slowly. Let's say it drops by 5 millivolts each frame. And so we keep writing. As long as it's more than 70, we are still not rested. So we see that it goes down like this, like this, like this, and all the way until it goes back to minus 70. So this is an example of a while loop. Now, what do you think would happen if instead of minus equals 5, I said plus equals 5?
I think it will go on forever.
Yeah, you're right. This would go on forever. I mean, maybe not forever because eventually computer might crash because the number gets too big and can't fit. But if it doesn't crash, then yeah, it will keep going forever. So yeah, it's very important that we don't write infinite loops. Basically, infinite loop is anything that doesn't stop because that can kill our app, basically. Keep it busy forever and even potentially make our computer just slow down and even crash. All right, this is an example of a while loop. Now I want to go through an example of a for loop. Here is what a for loop can do. So while loop just says that as long as some condition is true, I will keep doing these things. A for loop, on the other hand, says that I will do something for every element of a list. So in this case, for example, you remember we have frontal lobe tasks, right? And it says movement, consciousness, attention, morals. What if I want to print out every member of this list on the screen? How might I do that? So, well, I mean, one dirty way is to just say print frontal lobe tasks. It will just write them like this. But let's say I want a different format. Let's say I want to do it prettily, like a task that a frontal lobe does is, and then follow it up with something. But how would I do this? Well, actually, there are some ways. For now, let's comment this out so that it doesn't bother us because it writes a lot to the screen. Let's say, let's see the first task that a frontal lobe does. To get the first task from frontal lobe task, so frontal lobe task we know is a list that has movement, conscious, attention, morals. We would have to take an index out of this list. And here's what that means. We would open up the square brackets again and we would write 0. And in this case, we would see first task that a frontal lobe does is movement. Similarly, we can say second task that a frontal lobe does is, and in this case, we would say 1. And that would be consciousness. So in this case, we can see, let me just comment those out. So this is called indexing. And this allows us to take a specific element from a list. Let me just bring this line down, actually, so that we know what we're dealing with. So in this case, we know that this is at index 0, 1, 2, and 3. And yes, you will meet this a lot. Basically, in almost every programming language, counting is usually starting from 0. Why? It has to do something with how in early computers this was faster to calculate. But yeah, basically we're stuck with these rules that the first element is at index 0 and write it like this. So here we would say then the third task and so on. But what if I want to do this pretty format for any number of tasks? Like if tomorrow we have 10 tasks instead, I still want to be able to do it. Here's what I would do for that. I will get a for loop that says for task in frontal lobe tasks. So you remember previously that in was a check that checked if some given text was in a loop, a list. In this case, what this gives is that we would get each of them. Here's what I mean. Let's just clarify it. Task is now a variable. That will first be movement, then will be consciousness, then attention, and then morals. Let's just see. The task of frontal lobe is, and let's say, plus task. In this case, here is what we see on the screen. So we see a task of frontal lobe is movement, a task of frontal lobe is consciousness, is attention, and then is morals. So what the for loop does is that for each element of the list, in this case the list is these frontal lobe tasks, it will put the value in this variable that we defined here. We can call it whatever we want. We can call it literally whatever if we want. And then it will execute whatever code we put in here for that variable. So in this case, yeah, this will work just fine. Doesn't matter what we name the variable. You can see here, task of frontal lobe is movement, conscious, attention, morals. Now, this is just one example of a for loop, and there are many other examples of how a for loop might be used. But generally, every case of a for loop is that we take each element of a list, we put it in some variable, and then we do whatever we want with that variable. So another thing we might do with a for loop generally is, let's say we have a list of numbers, like let's say coins. Maybe we have some 5 lari coin, another 5 lari coin, a 10 lari coin, a 2 lari coin, and a 5 lari coin. And maybe we want to find out how much money we have in total. So for example, we could say total equals 0. And then for coin in coins, we could just say total plus equals coin. And then we might just say total. Let's see what that would mean. In this case, you can see it's 27. So the for loop can be used with any list. It can be a list of text, a list of numbers, a list of anything. And it will put each element into this variable, and then we can do whatever we want with it. Maybe print it, maybe put it in some variable, maybe get the sum, maybe multiply it, or it doesn't matter. Now, another thing we can do in a for loop, which is a powerful thing, is that we might want to stop early. Like, for example, let's say we have a lot of coins in here. Let's just write out a bunch of coins. But let's say as soon as we get up to 100, we want to stop. So what we can do here is say if total is more than 100, we can break. And here's what that means. This means that the moment we went past 100, we stopped our execution. And the other coins just won't be iterated through. So what this means is that first it became, let's just in fact write what the total was at each point so that we understand what happened. So we see here that at first the total was 5, then became 10, then 20, 22, so on and so on. and eventually it became 97, and then it added 17, became 167. At which point this statement became true, and we got here. And because we got here, we just called break, and that way we ended it. We broke out of it, and the execution ended. This is the main idea in a for loop. And by the way, this break also exists in a while loop. So let's just see an example of that as well. Let's say quite similarly to this. So this is one way to count coins. Let's say another way. So another way would be, while total is less than 100, just say that coin index, let's say, is 0 because we start with the first coin. And we would say total. So let's say coin, in this case, is coins at coin index. Then we can even increase the coin index. And we would say increase total by coin. And this would actually do the same thing. As you can see, it also printed 167. But now to understand why this was the same as this, let's check what's going on. First of all, would someone like to go through this with me so that we can figure out why this is equivalent to this? Okay, I'll just explain it again more slowly so that we can see the similarities, because even though the syntax is slightly different, these are actually doing the same thing. So let's first go through the while loop because it's more clear. So here's what we do. First, we say that coin index is 0, and we print the coin at that index. Why do we need to do that? To understand that, let's just remove all the print statements for now and simply print on the screen just coins at different indexes. Say coins at 3. What do you think coins at 3 will print? So, like for this list, what would be the element at index 3?
I think it's going to repeat the total 3 times.
I don't mean yeah, later, yeah, but I mean, let me just ignore these parts. Let's ignore all of this code for now. Let's only focus on these lines. So in this case, what we want to do is we want to take a specific coin from this list. So the way lists work is that we have indexes, and each element lives at an index. It's like an address for where
All
it.
right, yeah. Mhm.
So like
It's going to print 2, right?
yeah, exactly. So this will print,
Yeah.
see it? Here, it printed 2. So this prints 2, but if we want to print each of the coins, what we can say is we can say coin index, which starts at 0, and we can say while coin index is less than, let's see what the last index here should be. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's say at less than 12. Here's what we could say. We could say print coins at coin index and then increase the coin index by 1. So in this case, we would see each coin printed on a screen like that. You see? The reason why each coin got printed on a screen is because we can take any specific coin by its index, and then we increase the index to move to the next coin. So let's just break this down into smaller parts. First, let's say the coin that we are taking is coins at coin index. And of course, we could call these different names, but it's just more straightforward this way. And we could write some more complicated text here, like print coin at index. Let's turn this into coin index is, and turn it to text coin. So this way we can see more clearly. Like coin at index 0 is 5, at index 1 is 5, index 2 is 10, and so on. So here we can see each coin at an index. Is this part clear?
Yes.
So basically, yeah, each coin has its index, and we can access the coin by getting to that specific index. So now that we have coins, each one written in this coin right here, let's say we want to count the total. We'll just say total equals 0. And here, now that we have a coin, we can add it to our total. So let's just say total plus equals coin. And then we can say if total is now more than 100, we can break. So that we end this and don't continue any longer. And then we'll say print total. And let's see what will happen this time. Again, we get 167. But if we don't break, then we will get 297 because in total, they are 297. But if we decide to end the counting early, it will just end early. Yeah. So if we say if total is more than 100, I don't know, 180, for example, we will end at a different time point and so on. So for each moment, we can see where we would end. In this way, right now, what this code does is that it goes through the coin indexes, it takes the specific coin at that index, and then it does some calculations with it and breaks whenever it wants. So just this portion, which goes through the coin indexes, takes the coin at that index, and then moves to the next index, is the exact same thing as if we were to write for coin in coins and write something here like print coin maybe. We could also print coin here just to clarify that these are the same things. So here we can see, let's ignore the printing of total right now. So here, what we can observe is that this first one, the while loop, printed these values, and this for loop also did the exact same thing. So basically, the for loop is a shorter version of the while loop. So for coin in coins is the exact same thing as getting a coin index, going through it, taking a coin at each index, and then increasing the index by 1. Is it clear why these two are the same?
Yeah.
All right. We will have some more homeworks about this, so don't worry if it's not clear from the start. And now let's say that we define a task like that for breaking at a specific moment. Like, let's say what we want to do is that take as many coins as needed until you reach some X amount. So let's say take coins until amount. Let's just say needed amount and coins. Let's say we also pass the coins because maybe these are the coins, maybe some other list. So here is what I would want to do generally. Let's say in this case, we would say total is 0 at first. And then we would say for coin in coins, and in this case, we're talking about whatever coins we'll pass to this function. We would say just total plus equals coin. And if total is already more than or equal to what we need, we can end it. And either way, we will just return the total. And here's what that can give us. In this case, let's say print directly so that we don't bother with storing it in a variable. Let's say we need to collect 15 lari from these coins. What do you think would be the value printed on the screen in this case? So let's go through this line by line together. First of all, we can see here that there's a lot going on, but let's break it down. First, let's run it to see what happens so that we can then think reverse from it. So here we see that we got 20 printed on the screen. Now, why is that? By the way, let me see if I have a debugger in here. I believe I should. Yeah. Okay. So sometimes it's not obvious from the start how some code should behave, and it's hard to tell what's going on just by looking at the code. This is why there is this very useful tool called a debugger. Here's what a debugger does. So, yeah, it's all right. We got enough time to explain this. So I want to explain a debugger right now, and this will help you always, even when you're thinking on your own, when you're solving the problems, or when you're just learning, any moment. This is very useful and very much used at work all the time. So here's what debugger means. Basically, it means that you can put some breakpoints at any places in your code, and each time your code gets there, it will pause, and you'll be able to see what is stored in each variable. So let's use it right now. Let's run this with a debugger. So let me just click that. And we got here. So what happened is we defined this function. We have a coins, and we call this function right here, right? We say take coins until amount, and we give 15 and coins. So needed amount right now, here, by the way, on my left, you can see variables and their values. So we have variable called needed amount, which is equal to 15. And we have a variable called coins, which is just 5, this value. Now let's see what happens here. By the way, I'm clicking F10 to move. I will give you the tutorials and everything about this after the lecture as a reminder, but yeah. So basically we can see here every variable that we have. Like, do you see it?
Yes. Yeah.
So in this case, we have total that is currently equal to 0. And we know that coins is this list. And let's go through it. So first, we take the first coin. So coin equals 5. And after running this, total is also equal to 5, as we can see here. Now we check, is it more than needed amount? Needed amount is 15, so it's not more yet. So we take the next coin. Next coin is 5, so total now became 10. But it's still not more than 15, so we continue. And now the coin is 10, so total became 20. 20 is more than 15, so we come here and we say break. And because we said break, we exit the for loop and we no longer go through it. So now we come here and we say return total. In this case, total is equal to 20, and so 20 is returned and we print it on the screen. Did that make it more clear what is happening here?
Yes.
Good. So this tool is called a debugger, and you will be working with the debugger a lot because sometimes your code will get a lot more complicated than this, and it will be very difficult to tell what's going on just by looking at it. Or maybe there is some error in your code. Maybe sometimes your code works right, but sometimes it works wrong. And to figure out why and how to fix it, you will need to put debuggers in there. I mean, the breakpoints like this, so that your code pauses there and you can look into the values of each variable and figure out what is wrong and how to fix it. This is the main takeaway I want you to have about debuggers, which is that they let you to look inside the code while it's running so that you can figure out things on runtime. And by the way, runtime just means while the code is running. And by the way, speaking of runtime, there's a couple different types of errors that you should be familiar with. There's basically three main types of errors that we will encounter for sure. It's inevitable. So the first type of error is called a syntax error. This is when you write something wrong and so Python doesn't execute. So like if I say something like this, Python will not execute and I will just get an error. Name error because this name is not defined and I can't call something on it. So this is just syntax error because this doesn't exist. Another is a runtime errors. Like for example, if I try to access the element of an array that doesn't exist. Like what I mean is here, for example, for our coins, we know that the last element is at the index of 11. Let me just put this one up. We know that the last coin is at the index of 11. So what happens if I go to the index of 12? We will get the error that says list index out of range. So this is another error. And there is also a logical error. Problem with logical error is that we won't actually see an error printed on the screen because the code will execute just fine, but it will do the wrong thing. For example, let's say add numbers is our function that's supposed to take a and b, but instead of adding them, it subtracts them, let's say. In this case, this code will run just fine, but it will not do its job. So in this case, it's supposed to say 7, but it says -1. This is an example of a logical error because the code executed just fine. No error was printed on the screen because there was no error. But we know that this is doing the wrong thing because it's supposed to be adding and it's subtracting. I mean, in this case, this is obvious that this is a wrong logic, but sometimes it's not so obvious because sometimes there might be a more complicated code where maybe we were supposed to write more than or equal instead of more than, or we were supposed to write like more than instead of more than or equal, or it could be any such tricky case. So what to remember is that we might encounter syntax errors, we might encounter runtime errors, and we might encounter logical errors. Basically, syntax error just means that we wrote something that doesn't make sense at all. Runtime error means that we wrote something that crashes, like we wrote a division by 0, or we try to access an element of a list that doesn't exist. And logical error is just we don't crash our code, but we're doing the wrong thing. Is this clear?
Yes.
Okay. Now, again, in our homeworks, we'll deal with a lot of different functions, and we will have the use cases where we want to have to use loops. In this case, let's just go back to what we wanted from the start. And let's say we want to make a function that will take the list of tasks and output them, and also take the name of who it is. So let's say a function that will say write tasks of lobe. It will take the name of the lobe and it will take the tasks of the lobe. And in this case, it will say maybe tasks of lobe name. And then we'll just say for task in lobe tasks, maybe just print task. And now we can just say write tasks of lobe frontal lobe tasks, for instance. This would give us tasks of frontal lobe are movement, consciousness, attention, morals. Similarly then, let's give this inside here so that basically there's a new line after it and we can more clearly see the difference. Now let's say write tasks of temporal lobe, for instance. In this case, we would see tasks of temporal lobe are only hearing because we don't have anything else in there. We could also then say write tasks of lobe, let's say parietal lobe tasks. And it will say just touch, pain, temperature, spatial perception, and so on. And so the idea here is that we wrote a function that takes 2 arguments. And by the way, a function can take as many arguments as we want. And the arguments can be anything. It can be a list, a number, a text, whatever we want. So in this case, we have a function that takes the name of the lobe and the tasks, which is a list. It just says, prints to the screen the tasks of and the name, and then it goes through the list. So for each task, it prints the task, and then it prints the end line so that we have this separation between them. Is this clear?
Yes.
Okay. This is a basic use case of a for loop and a while loop and also lists. We will see some more examples later when we dive more deeper into lists. But for now, what you need to understand is that this is how most of the code works. So generally, we have for loops that go through elements of a list. We have while loops that keep running as long as some condition is true. We have functions that can take some arguments and return some values. And we can print stuff to the screen, and we can take input from the user. These are the main things that I wanted to cover again today, because covering them once is not enough for them to get ingrained. And I will upload some homeworks around this stuff, and I encourage that you spend your time on the homeworks. Try to struggle on the homeworks so that the more you struggle on it, basically the better you will understand and you will develop the intuition over time. And that's basically it.